Okay, so let's get going. Okay, so I think I don't need to repeat the setup again. So maybe I need some time, but not to right now. So okay, so I think last time we have that so sync like so this is x, right? So suppose that so you have this x and then you have the y here and then here you have this x tilde and then you have this y tilde. Okay. So the case where so the case where you pick the so if you can pick the evenly covered domain, you and v such that they are disjoint. So then in this case it is automatically empty. Okay, it's empty. So it's empty for all such like deck transformation. So therefore, it should be so the set where it's not equal to the empty set is basically the null set. Okay. So yeah. So therefore the okay. So and then the null set is finite. Okay. So by definition of finite. Okay. So okay, so now suppose that you don't have this non-empty intersection, right? So suppose that so suppose that you have this intersection as non-empty, okay. So if that's the case, then what's happened? So here you have this. So I think the issue is that if you pick any point, let's say k. Oh, k is used here. So maybe I'll use s. Okay. So that s. So for example, this is like the u, this is like the v. Okay. So u and v they are evenly covered the domain. Okay. So suppose that this s is in this u intersect v, right? So then I want to analyze what is this gamma inverse of s, right? So okay. So okay, so here, okay, so here, this gamma inverse of s. So this is like the fibers, right? Wait. Okay, I think it would only intersect with this x tilde once. Okay, let me think. Okay, so by part E, we know that, so if U is an evenly covered domain in X, and then U naught is a component of U tilde, which is gamma inverse of U, then the set. Yeah, so basically, the idea, okay, so what do you want to show? Yeah, I was trying to say that basically the idea is that if you apply so this is like a evenly covered open set that contains this x tilde on the image set. So basically the idea is that if you apply the dash transformation, then the image of this neighborhood will be destroyed from. It will be also another neighborhood, but it will be destroyed from the original one. I think this is what it's trying to say. It's a component. so I think there might be two cases, right? So okay, so the first case is that you have this so basically the idea is that so we can let this so we can try to let this so we let this so we let this V tutor to be the connect component to be the component of this gamma inverse of V, such that this Y tutor is in V tutor, and then we let this U tutor to be again like gamma inverse of U, such that we have this this X tutor is contained in this U tutor, right? Okay. So okay, so yeah, so let's say first. So here, if we have this U tutor and then this V tutor is an empty set. Okay. So then what will happen? Okay, so okay, I want to say that okay, so I want to say that I want to say that there is a so basically you let gamma inverse of Y. Y there is a Carnot projection. Okay, yeah. So okay, so let's see. So yeah, I think the point is that because this F is like a point that's in common, right? So basically, so if the intersection is empty, then I can produce a so this S that's in the intersection. So we can let this S tutor to be equal to so basically I would say it's the lift of this because yeah, so let's say this gamma restricted on so that is V tutor, right? V tutor inverse. So it's exactly the lifting of this or like, yeah, so the lifting of this S under this given cover, okay, under this cover. So let's say that this S tutor is here. So then, okay, so once you have this S tutor, then you can locate a, yeah, so you can, so what do you do? So then, so we can let maybe u tilde prime to be the component of this gamma inverse of u such that this s tilde is in this u tilde prime. Okay. Okay, so let's see what happened. So, and then, okay, so what do I want to say? So, I want to say that, okay, okay, so maybe I can let this x tilde prime, okay, to be defined as this gamma. So I want to say that this x tilde prime is like the, so suppose that, so okay, so this is the neighborhood, let's say u tilde, okay, I just changed it like the little, yeah, and then this is the neighborhood, okay, so this is neighborhood u tilde prime, and then I wanna pick a point, let's say I wanna pick like the limiting of x relatively to this u tilde prime to be x tilde prime, okay. So that x tilde prime to be the gamma restricted on this u tilde prime inverse of this x, okay. And then okay, so I want to say that there is a unique deck transformation of that maps this x tilde to x prime tilde. So oh, okay. So I think we showed the last time, right? So yeah. So by okay. Okay. So by so actually, this is the first theorem we proved in this chapter of deck transformation. So, so remember that what we do is that we define a bijection between the deck transformation group and so okay, so the idea is that we fix a point in the universal cover. And then, oh sorry, we fit a point in the covering space, and then, oh yeah, sorry, yeah. So okay, so basically what we do is that we have this x tilde as the like as the universal cover, right? And then, so this is like the universal cover. And then we fit a point. Point, and then we consider all the fibers, like F to be the oh sorry, X tilde, X naught, right? And then we say that the identification of this element of the deck transformation to its image of this x naught tilde is a bijection, right? So we show that. So we show that the so what we showed is that, so what's the result is that so the map from the deck transformation of this gamma to f given by this phi goes to phi of a bijection. Okay. Okay. Again, this x0 tilde is like a arbitrary point. It's any point we fix. Okay. So yeah, so this is like a theorem 10.4.2 part A. Okay. So by part A, okay. So there is a unique wait. Oh. Yes. Okay. So there's a unique, let's say, small gamma in this the deck transformation group such that this small gamma of x tilde is equal to x tilde prime. Okay. So therefore, then let's see. By part E, yeah. So same theorem. Okay, which yeah, I think I left. So we have that. So we know that this gamma of this U tilde is equal to okay. Okay, so I'll leave it to you to verify. I think this gamma of U tilde is just the U tilde prime. Okay. Okay, so then so what do I want to say? So Okay, so what do I want to show here? So, okay, I want to show that this gamma X property is continuity, right? So this means that the set of non-empty wait. Yeah. Okay, so I want to show that the set of all okay. Okay, yeah, so we want to show that yeah, so we want to show that this gamma acts properly discontinuously on this X tutor, right? So, and by the previous lemma, so this is equivalent as for each point xy in this X tutor, right? Then we have this, we would have this, there is a neighborhood, the u of x, v of y, such that this gamma of this, so that this gamma of u v is empty for all but finally any for it's not empty for finally any gamma of gamma. Okay. Okay, so we want to show that. Okay, so we want to show that this gamma of this u tutor intersect this v tutor is non-empty for finally many gamma in gamma. Okay. Okay, I think the only choice for this gamma is the one that's yeah, it's this one. So yeah, but okay, so let me try to show that. Okay. 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 So now, okay. So now, suppose you have this. Okay. So maybe okay. I want to show is that so here's my conjecture. So if let's say that you have this gamma prime of this u tutor intersect this v tutor is not empty, so then you have this gamma prime okay. Suppose we have that suppose there is another that transformation such that yeah, so maybe just that, okay. Such that this gamma prime U intersect this V is not empty. Okay, so then, so yeah, so the idea is that, so since it's not empty, right? Yeah, so since this is not empty, you can do like a projection down and okay, let me just say, okay. So in the empty, then let's say there exists a, so now that, let's say this C tilde, okay, C tilde be the gamma prime of this U intersect the V tilde, gamma prime of V tilde intersect the V tilde, okay. So then, so now do that. Okay. So okay, now you do the same argument. So that C to be the projection of this C tilde, and then yeah, so C is the point here, and then what you do is that you so now do that. So I want to say that if you do that U to the C to be the set that's equals of U such that yeah, so such that this C tilde is contained in this set. Okay. What do you want to say? C is contained in that. Oh, C tilde. Okay. Okay, I want to say that this S tilde is also contained in that set, but why? So you have the, yeah, you have the elliptic, right? C is in U. Deck transformation. Okay, so namely, can there be a set that wait, no. Okay. Okay. So wait. So I want to say what I want to say is that this yeah. So I want to say that so this C tutor mass lies in wait, no, not wait. Yeah, so this C tutor must wait. Must lies in yeah, this C tutor must lies in this set. U to the prime intersect V tutor, right? Because why? Okay, because okay, so because so because this C is yeah, because this C lies in intersect B, right? So so why is that? So okay, maybe let's do this. So this implies that okay. Okay, so here's my another claim. This C is lies in this U intersect V, right? Yeah, I think it's so because yeah, it lies yeah, basically it lies in V because you do the projection, then it's on V, right? And then it lies on U because it belongs to the gamma prime of U tutor, right? So this gamma is a yeah, because this gamma prime is in the Dix transformation, right? So therefore you have the gamma, the big gamma composed with small gamma of this C, which should be equal to the big gamma of C, which is C tutor. Yeah, which is equal to this C, right? Yeah, so this is like a small gamma here. Okay. And then because wait, sorry, the lost. Let me see. Oh yeah. So yeah. Sorry, I think it should be goes in the other way. So yeah, it goes in the other way. So yeah, so C tilde in this So gamma prime of U tilde implies that maybe let's say that this C is equal to small gamma prime of C tilde prime. Okay, so where this C tilde prime is in U tilde, so then this implies that gamma of C tilde, which is equal to gamma of gamma prime of C tilde prime, which is equal to the big gamma of C tilde prime, and then by definition this lies in U. Okay. Okay, so yeah, so once I show that, then yeah, so then since this C also lies in U tilde V, so so since you have this this is like a biholomorphism, right? Yeah, I think maybe okay, so why did C U tilde prime